A quadratic is a function that has degree 2. So a quadratic, the standard form is y equals ax squared plus bx plus c. Okay, a linear function looks like y equals mx plus b. So a linear function has degree 1 because the exponent of x is 1, but a quadratic is degree 2. So the shape of a quadratic is called a parabola. So a parabola has a vertex. So the vertex of a parabola looks like this. This is called having a minimum value. So this has a minimum value. And a parabola can open down and have a maximum value. So to determine whether or not a parabola opens up or down, you want to look at A. So if A is greater than 0, that means it's positive. The parabola is going to open up and it has a minimum value. And if A is less than 0, it's going to open down and have a maximum value. Also, the A can tell you whether a parabola is narrow or wide. So if the absolute value of A is greater than 1, it's going to be narrow. So whether it's positive or negative, the farther a number away is from 0 on the number line is going to determine how narrow it is. And if the absolute value of A is less than 1, it's going to be wide. So the formula to find the vertex of a parabola is, a vertex is an ordered pair, so you want to find negative b over 2a. So negative b over 2a is the coordinate, is the x coordinate. And then a vertex has an x and a y, so what you're going to do is you're going to get your x value, which is negative b over 2a, and plug negative b over 2a in for x to get y. And we'll do numerous examples on the next page. The axis of symmetry is a vertical line that goes through the vertex, that is the line of symmetry. So, and that's, since it's a vertical line, it's always going to be x equals, and it's going to be the x coordinate of your vertex, so it's negative b over 2a. And the y-intercept is where a parabola crosses the y-axis. So wherever it crosses the y-axis, x is 0. So it's also going to be, in standard form, it's going to be your c value. So it's going to be 0, c. Example 1, identify the vertex and the axis of symmetry of each parabola. Identify points corresponding to P and Q. So the vertex is this point right here. So the vertex is going to be 1, negative 1. The axis of symmetry is going to be the same, it's going to be the same point, right here. The axis of symmetry is going to be the same point as the same x value as the vertex. So if the vertex is at 1, negative 1, the axis of symmetry is going to be x equals 1. And a point that responds to P, or corresponds to P, is going to be the same distance across. So that point right here is going to be 3, 3. And the point corresponding to Q is going to be directly across from the axis of symmetry, and that's going to be at 0, 0. So when you figure out the corresponding points, you want to draw your line of symmetry. So this vertex is going to be at negative 1, positive 2. So the axis of symmetry is going to be equation x equals negative 1. And a point that corresponds to P is going to be 0, 1. And a point that corresponds to Q is going to be negative 3, negative 2. Okay, example 2. Use your calculator to come up with a quadratic remodel. Just like how we did linear regression, you can do a quadratic regression. So what I'm going to do is I'm going to put in my L1 the numbers 1, 2, 4, and 3. So I'm just capturing the x coordinates. And then in L2, I'm going to put in 4, 7, 6, and 10. So I press stat on my calculator, edit, and put these into L1 and L2. So I'm going to do that right now. So I do stat, edit, and then put 1, 2, 4, 3, and then 1 goes with, and then L2 I'm going to put 4, 7, 6, 10. So to find the quadratic model, I go to stat, calc, and you want to do the quadratic regression. So the quadratic model, I'm going to do stat, calc, and this time instead of doing linear regression, I'm going to select quad regression. So press enter through, and you're going to get an A, B, and a C. So my model is going to be y equals A. So A is negative 1.75 x squared. And then my B is 9.65, so I write plus 9.65x. And my C is negative 4.25. So my next question is find y when x is 10. So you want to plug in x equals 10, which I'm doing right now. I'm substituting 10 in for x in my equation, and I get negative 82.75. So what I did is I plugged x equals 10 in right here, and I put 10 in parentheses. Okay, so next example. The profit in millions of dollars with respect to ticket prices can be modeled with a quadratic function. Write a quadratic function for the data below. Round the nearest thousandth. So my thousandth is going to be 3 decimals. So I'm going to put these numbers in my L1, these numbers in my L2, and I'm going to put the quadratic regression. So I will press pause and come back. So whatever, this is for a concert. So if a ticket price is $200, they can expect a profit of $308 million. If the ticket price is $250, they can expect a profit of $352. So they're trying to figure out what per ticket price should we set in order to get the maximum profit. So my equation, when I round to nearest thousandth, is going to be y equals negative 0.004, because I round to nearest thousandth, x squared, plus 2.537x, because B was 2.53657 and I rounded, and C is negative 50.514. So what should the ticket price be to maximize the profit? So I need to find the maximum. So if you remember this parabola, because A is negative, it's going to open down. So it's going to have a maximum. So what ticket price? So ticket price is your x. So I'm going to find the vertex. So I'm going to do just the x coordinate of the vertex. So it's going to be opposite B divided by 2A. So this is going to be opposite of 2.537 divided by 2 times A, which is negative 0.004. So I'm going to put that in my calculator. I usually just put 2A all in parentheses. So 2 times negative 0.004 is $317.13. So whenever you read maximum or minimum, or the highest point or the lowest point, and it's a quadratic function, you want to find the vertex. In this case, I only need the x-coordinate of the vertex because it asks for the ticket price. If they ask for the profit, I'd have to plug in 317.13 in for x. And then predict the profit if the ticket price is 100. So let x be 100 because ticket price is 100. So I'm going to plug in 100 into x right here. So it's negative 0.004 parentheses 100 squared plus 2.537 times 100 minus 50.514. So the profit is going to be 163 million. Okay, example 4, graph each parabola, identify the vertex, the y-intercept, and axis of symmetry. So remember, for the vertex, you want to do the formula opposite b over 2a, and then you plug that in for x. So this is going to be opposite b. Well, b, there's not a b term because there's not a term in front of x. So this is going to be 0 over 2, and your a is going to be the number in front of the x squared. So your vertex is going to be 0, but then you have to plug 0 back in to find the y. So if you plug in 0, you get -5. So your vertex is 0, -5. Your y-intercept is also -5 because y-intercept you plug in 0 for x. And your axis of symmetry is x equals 0. So I don't really have any other points. So what you could do is you could plug in different numbers. So I'm going to plug in 2 and -2 in for x, because you can do that with any function. Plug in a number to get what y is. So if I plug in 2, I get 7. So 7 is a little bit off the chart right here. And also, since this is my line of symmetry, if I plugged in -2, because of symmetry, I'd also get 7. So you have this narrow parabola. Okay, second one, vertex is -b over 2a. So a equals 2, and b, there's not a number in front of x. A is 2, b is 0, c is -4, so b is going to be 0. So it's going to be -0 divided by 2 times 2, so that's just 0. So if you plug in 0, you get -4, because 2 times 0 squared minus 4 is -4. And your y-intercept, again, for your y-intercept for any function, you're going to plug in 0 for x. So that's going to be -4. And your axis of symmetry has to be a vertical line, so it's x equals 0. So all I have is my axis of symmetry and my vertex. So what you can do is you can plug in a number for x. So I'm going to plug in 2. 2 times 1 squared minus 4. So that's going to be -2. So 1, -2, and -1, -2 is a point. And just so I'm a little neater than I was in the last one, I'm going to plug in 2 as well. So 2 times 2 squared minus 4. So 2 times 2 squared minus 4 is 4. So I go up 4, up 4. And I can use symmetry.